Good afternoon, ladies and gentlemen of Algebra 2 Honors. We are going to be working on section 3.1, which is quadratic functions in vertex form, graphing them. And in this set 1 through 11, whose handout you have, is the most challenging problems are number 1, ironically enough, and number 11. So I want you to go ahead and just see if you can look at number 1 and try to make some sense out of it, and then we'll go over it here in a couple minutes, all right? Okay, what do you think about this one? What do you think about this one?
Is the F the same as the A?
Is the F the same as the A? Oh, no. Because what it is, this is function notation, F. So in other words, we're saying that the output value of the X value of H, so this H plus 5 represents an X value. And if we plug in this X value, we get an output of negative 19. That's what that means. What do you think, anyone? One thing I found that helped with this is drawing a table, drawing a graph to try to figure things out. So what do you think? Anybody have an idea? Does anybody have an idea if even A is negative or positive? Negative, you think, Ben? How do you figure A is negative, Ben?
When both of the answers, negative 19, negative 4, are negative.
Okay. It says both of the output values are negative, and so consequently, wouldn't A be negative? That's your logic. We'll see how it holds here. What I did on this was made a table. So if you make a table, you have x and f of x. And the first thing I'll put is the vertex. What's the vertex going to be? Letters. It's going to be h. And if we put in h, what's our output value going to be?
Okay.
Okay, J says K. Yeah, J, you're right. Okay. So now we have f of x plus h. So we don't know what h is. But we know that if we add 5 more to it, 1, 2, 3, 4, 5. So over here, if we have an input value of x plus h, what is our output value? What is our output value? Negative 19. And we don't know what h is again. If we go to h minus 2, so we put h minus 2 over here, what is our output value? Negative 4. Okay. Does that help you see what's going on here? So what do you know about this?
It's negative.
Pardon me?
It's negative.
What's negative?
H would be negative. Or K is at least.
Well, K, here's the thing about K that's crazy, because K could still be higher than negative 4, right?
Oh yeah, because it's the alpha.
Yeah, so I'm not 100% sure, but, because that's a vertex.
This is going down.
Okay, let's look at this. Do we know what H is? No, we don't. But, if we have an XY coordinate plane, and we have an axis symmetry formula, X is equal to H. If we come over here 5 to the right, 2, 3, 4, 5, we know our output value is negative 19. Because this is going to be H.
Thank you.
This would be H plus, comma, negative 19. I don't know why I put X plus H. It should be H plus, it should be H plus 5. So, and then if we take X, H minus 2, what is our output value? Negative 4. So here we have this point here and this point here. So what does that tell us about what's going on here? Let's go on here. It's asking find f of x minus h. So if we put h minus 5, what is our output value going to be here?
-1.
No. We have f of h plus 5 is negative 19. So what's going to be f of h minus 5?
Negative 1. Oh, negative 19.
So that's going to be right over here. And what's going to be f of h plus 2? Negative 4. So we have negative 4 over here. So what is this going to look like? It'll look something like this, right? Do we know if k is positive or not? No, we don't. Do we need to know? So what about a? Is a positive or negative? Okay, a is less than 0 because what?
Graph opens down.
Because the graph opens downward, because, and Gabby's right, because, and how do we explain why the graph opens downward? How about as x values get closer to axis of symmetry, to the axis of symmetry, output values are increasing. Okay, so really that's it. Now to me, what's the hardest part of this problem?
First starting.
Just starting it. To me, the hardest part of it is not knowing what h is. Right? So you don't know, and we still don't know what our axis of symmetry is, because it's just represented algebraically as h. I mean, it could be over here where I've drawn it, over here where x equals 10, or it could be over here. But does it matter based on what we're given? No. So we can figure that out. Now, we had a student, Stephen, in 7th period, who figured out that we could actually figure what A is. And so I did figure it out, but how do you think he told me how to figure out what A is? What did Steve tell me to do last period to figure out what A is, which I did figure out? What did he tell me to do?
Plug in something.
Yeah? What did he tell me to do? Well, I'll tell you what he did. He said that we could take those points and enter them and run a quadratic regression. And I did that, but I had to choose a value for k. And so I put those values in there. I put 3 of these points. I think I put these points here. I made this 5. I made h equal 5. So I put 5. So I made this 10, comma, negative 4, 0, comma, no, 10, comma, negative 19, 0, comma, negative 19, and 3, comma, negative 4. And when you do that, we go to stat, calc, 5, enter. So here we get, let's see, E doesn't give me that in Vertex form, so I still don't have what A is. But I do have what A is, I don't have the vertex. It says B is equal to 7.14, but still doesn't tell me about X symmetry. Negative B over 2A, I can figure that out. But A is equal to negative 0.714, so that's what A is. So we have the actual equation right here. So I thought that was interesting. Okay, next we go on to number 2. And I'm going to do this myself, and then I'm going to choose randomly people to help me with the other problems, all right? So here, we're going to identify the X symmetry. Well, first of all, we know that our vertex is equal to the point H, comma, K. So in this case, we have our vertex is going to be 3, comma, 6. And so for axis symmetry, it's going to be the formula X equals H, which in this case is 3. So that's our axis of symmetry formula. And then we give the function's maximum or minimum value. And by the way, it would really help to sketch a graph of these things too, first of all, if you have trouble getting started. What is the function's maximum or minimum value? Do we have a maximum or a minimum value here? Do we have a maximum or a minimum value here? What did you say? Do we have a maximum or minimum value?
Yes.
Yes, and what is that?
Is it positive?
It's a minimum.
It's a minimum. And what is the value of our minimum? So y is equal to 6. How do we know that? Because this is our vertex. And what tells you this is a minimum and not a maximum?
This is positive.
What is positive?
The K.
No, A is positive. A is positive, so therefore we have a minimum. That minimum is K. And so to sketch, I told you to sketch a graph of this thing. So if you sketch a graph of this thing, it looks something like this. So we have 3, 6. So here's our vertex, and here's our parabola opening up like this. And here's our axis symmetry, which is X is equal to 3. So it says, what is its domain? What is our domain of this? All real numbers. What is our range going to be?
6.
So 6, comma, infinity. Is that right, Gabby? Yeah, that's right. And so this function is increasing on what interval? 6 to infinity. Is that right? Think about this. This says intervals where, these two words together, intervals where, what does that mean? Look over here where Addie is. What does that say? What does where say? What is where? Is that an X word or a Y word? It is an X word. So what is where? So what is going to be? What's going to be here? So increasing 3 and decreasing on what interval? Infinity 3. And so these will be our answers for number 2. So I invite the audience to go ahead and work out number 3, and I'm going to call on somebody shortly to help me out with number 3. All right? Okay, let's go ahead. Okay, I'm going to choose someone to help me here. This is a random pick here. It looks like Gabby is our first victim on this deal. Could we have picked anybody better than Gabby to help us out on this?
Yes.
Ben.
Gabby, you're not getting a lot of love. But Gabby,
It's okay.
I think we should pick Riley.
Gabby, I have.
Yeah.
Riley.
Riley will have his chance. Okay, Gabby, what do we got?
Well, I'll look at Vertex first.
Okay, so Gabby tells me Vertex first. And what did you get for your Vertex, Gabby?
8, comma
8, 1. Okay, everybody okay with that?
1.
Okay, what next?
Axis of symmetry. We got x equals 8.
X equals 8. Are we okay with that? Okay, next, maximum, minimum value.
Maximum. Y equals 1.
Y is equal to 1. Is everybody okay with that?
The domain is negative infinity to infinity.
So domain, she says, negative infinity, greater than negative infinity, less than infinity. Okay, range.
I have negative infinity, comma 1, and bracket.
Okay. And increasing on what interval?
Does it, does the increases are 8, negative 8, or?
I'll put negative infinity to 8.
So negative infinity, 8, you say, negative infinity, x equals 8. Okay, I think that looks good. So where are we decreasing by process of elimination? 8 to infinity. Okay, did you sketch a graph of this, Gabby?
I'll put it,
You put it in the calculator, take a look at it. And this really is kind of meant to be a non-calculator thing, but if you use your calculator. What I'd like you to do on these, if you can, is to try to work it out by hand first, and then graph to confirm. So we have 8, 1, and so the thing is going to look something like this, right? And we see everything is in place. All right? Okay, good. I want you to go work on number 4. I will choose somebody else randomly on number 4, okay? So that was just That was just pretty cold there, Gabby. All right. Calling somebody here. Goodness. Okay, let's see, see who we have next to help us out. All right, Jay. Got you, Jay. All right. Jay, what do you think about this?
So for the vertex, I got -4, -8.
So Vertex, he gets -4, -8, is that right?
Yes.
Okay, how does that portend for everything else then?
The axis of symmetry is x equals -4.
So he got axis symmetry x equals -4.
And there's a maximum of y equals -8.
Y is equal to -8.
And then the domain -infinity to infinity.
Range,
-infinity to -8 with a bracket for the -8.
-infinity, comma, -8, he says bracket. And then,
Would be increasing on -infinity to -4.
infinity up to x equals -4 and decreasing
-4 to infinity.
-4 to infinity. So how did you do this? Did you do this first without a calculator? Did you check with the calculator? See, Jay is just like, he didn't even check with the calculator. Anybody check this with a calculator?
Gabby did.
Gabby, he's right, isn't he? Man, that was really good work. Thank you, Jay. Okay, go ahead and work number 5. I'll choose another volunteer. Number 5, Jay. Okay. Let's go ahead here, see who we get for this. Looks like it's gonna be Marcus.
It was almost rising. He got scared.
Okay, Marcus, we got you this time, Marcus. What do you think, Marcus?
The vortex is -2, 9.
Okay, Vertex, he says it's going to be -2, 9. Okay, good. What is our axis symmetry?
-2.
You meant to say x equals, right, Marcus?
X equals negative
Okay. And then our do we have maximum or minimum?
2. That I do not know.
Okay. Is A greater than 0 or less than 0?
Greater than 0?
Greater than 0. So which way is our parabola opening? Up, right? And so if the parabola is opening upward, does that mean we have a maximum or a minimum?
And, oh,
Minimum, right? So we have a minimum, and that's going to be y equals 9. He says questioningly. But is he right about that? He's right about that. Okay, good job, Mark. So let's keep on going here. What's our domain going to be?
Negative infinity, positive infinity.
And what is our range going to be?
Negative infinity and 9.
Like that?
Yes.
All right. Anybody have something to add about this?
I put the 9 in the negative infinity.
Yeah.
But it should be negative.
Like 9.
Range, I got 9 infinity.
9 to infinity. Okay. Marcus, people are saying 9 to infinity. Why is that? Is that right? Because if we have a minimum, isn't our minimum going to be over here? Isn't it going to be like this?
Because the 9 is positive, it goes forward.
And so, it's not because 9 is positive, it's because 9 is our lowest value. That's why it goes first. Well, okay, if we look over here at 4, we have A is less than 0. And so the first thing on a range that comes first is negative infinity and goes all the way up to negative 8. Here, K is going to be, in this case, our minimum value. And so therefore, if that's our minimum value, it has to come first in interval notation, and will go up toward infinity. Okay, where is the function increasing? Increasing on what interval?
Negative infinity to negative 2. Oh, wait, negative 2 to negative
-2 to, okay, let's take a look at this. Let me draw a little sketch here. Okay, we got -2, 9. So here's our vertex at -2, 9. And we know the thing's going like this, right? So where are we increasing? From x equals -2. Starting at -2, increasing. Where are we decreasing?
infinity to negative.
Okay, negative infinity to -2. Okay?
Wait, why would it be negative infinity?
Because we're starting over here on the left. We're decreasing
Oh, okay.
all the way from greater than infinity. Now, when you said that you didn't understand, I said, man, maybe I made a mistake.
No, I
No,
got it.
that looks good. Okay, is everybody good on this? What I want you to do is look at number 6. Number 6 is a matching problem. It should just take a couple minutes to do. And then we'll look at number 7. Okay. What did you get for this one here? D is the first one? Because if we have x plus h, that's going to be negative. That's going to be D, right? Okay. Then this one's going to be A. And this next one's going to be B, you say? Okay, yeah, I think that's right. And then by process of elimination, C. Okay, so that should be a pretty simple exercise. Now, we get to 7 and 8, and we have completing the square, and it was last Friday that we talked about this. Does anybody remember something that far back? Gabby's nodding her head yes. Anybody else? Well, so what I'm going to do is I'm just going to work out number 7, just sort of, I hope to rekindle some remembrance here. And then I'm going to pick on a volunteer for number 8. How's that? So we're going to rewrite this as, I want to put x squared plus 6x here inside the parentheses plus some number that I haven't figured out yet. And then I'm going to subtract that same number, whatever I added here. And then finally I'm going to bring this minus 3 out on the right. And so how I'm going to figure out what number goes here to make the perfect square?
Times 6.
Times 6, you said? Okay, what do we have to do first to that 6? We have to divide that 6 by 2. So if we take 6 divided by 2, what do we get? 3. And then we take this 3 squared and get 9. So 9 should be the number that completes our square. And if we added 9 over here, what do we have to subtract over here? We have to subtract the same thing we added to preserve the value on the left side. So now we have x, what, plus what? X plus what squared? X plus 3 squared. And then what do we have left over here?
Negative 12.
Minus 12. So here we have our completed square vertex form. This is identify the maximum relative value and the value of x for which this occurs. So what is, do we have a maximum or minimum value? We have a minimum of negative 12, or I could say y equals negative 12, and where it occurs, where x equals, where x equals negative 3. So here we have our minimum value of negative 12 where x equals negative 3. Go ahead and work on 8, and then I'm going to call on somebody in just a couple of minutes to help with that. Okay, here we go. Peyton? Peyton, you are it. All right, Peyton, what do you think?
I don't know.
So we're going to put x squared minus 10x plus something here. And then we're going to subtract something, and then plus 11. What is going to go right here? 25? Is everybody okay with that? We take negative 10 divided by 2. We get negative 5. We get negative 5 squared is 25. Looks good. And what goes out here? Minus what? 25. So what do we have? We have x what squared? X minus 5 squared, and what goes out here? Minus 25 plus 11, minus 14. And so do we have a minimum here? So we have a minimum of what? Y equals negative 14, where x equals 5. And so this is going to be our answer here for number 8. Now, I think we're actually ready to go on to 9 and 10. As you can see, they have just about a little bit of a notch of a higher degree of complexity. So I want to just stop class right here today, and we'll just resume on 9 and 10 tomorrow, okay? Is everybody good with that? Thank you, everybody. Appreciate everybody participating on that.